Stars are whispering tales of old, planets spinning, stories bold. Life is dancing through the night, countless worlds in the starlight. Galaxies full of mystery, infinite in their history, beyond our dreams and our sights. Life blooms in the cosmic lights, dancing on the edge of space. Take me away, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Nebulas with colors bright, birth new wonders in the light. Comets trail their sparkling tears, life endures through the years. In the silence of the void, every heartbeat is enjoyed. From the depths and to the heights, life expands through cosmic night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night. Dancing on the edge of space, and off we go, feeling the universal grace. In the dark our hearts ignite, life across the endless night.
Yeah, just get right into it. Look at that. Hey guys, how y'all doing? I'm Mark D'Antonio here. I'm gonna be connecting with Daryl to see if we can get him back online for the next stream. There's not a whole lot of time this week. This is probably the only stream I can do because, as you saw with the chat, if you're watching it, the chat there, I'm gonna be in Nova Scotia Thursday because I'm speaking at a conference up there called the Shag Harbor event, and my talk is going to be about the way in which I believe, along with many physicists and astronomers, is the only way that unidentified flying objects or craft from other worlds could actually be here, and the technology that they use, and that's pretty cool. And so that talk should be about an hour, but last time I gave it with questions and the people just sitting there with their mouths open going like, wow, this ties everything together that we know. It could end up going longer, but we'll see. I have to keep strictly timed because they have a schedule up there. This will be my first time at Shag Harbor, and in Nova Scotia actually, so I don't actually know what to expect. Ronald is here. He says, say hi to Amanda and her mom and dad. Well, I won't be seeing Amanda. She's in Sydney. I'm going to Halifax. Amanda was the former co-host on Sky Tour Radio, our Wednesday night radio show from 8 to 10 p.m. Eastern on KGRA out of Ogden, Utah. And then we have she used to be a co-host here on this show as well, our Sky Tour live stream as well. Then she had things she wanted to do with her life other than waste her evenings with us, which is fun. So Daryl came in, and he's still with us. I just have to get him on. He's been under the weather. I haven't checked with him lately, but he may be okay right now. I'm not sure. But I didn't have the time to get him all straightened out for tonight's stream. So I got a few things going on. We got this thing here. This is a really interesting object. It's called Measure 11. If we label it, you can see it's right there. It's called M11 right there. It's also known as the wild duck. All right, wild duck cluster. Why people call it the wild duck, I don't know. Does it look like a cluster of ducks flying? Again, somebody somewhere must have seen a cluster of ducks flying. Don't know. I want to say hello to Kathy Messick, who was first. Thank you, Kathy. You're awesome. All right. And then we have Kevin from Vancouver, British Columbia, who's joining us. Hey there. Rodney Cox is with us. And then Sam S., Daisy and Zoe are here. And Rascally Rabbit, Curtis Horn. Good to see you, Curtis. And then Becky, who is from Nova Scotia. So I guess Becky knew I was going to be speaking up there, so she came in to say hi. It's very nice. Nice to see you too, Becky. Maybe I'll meet you at the Shag Harbor event. And then Tony Lowe's with us. Nice to see you. Rascally Rabbit's with us. ERRT Radio. That is Ronald. Made it to a live show finally. Well, we're gonna go earlier, and I mean, when I noticed it, I could have started this at 10 o'clock if we wanted to look at just the moon. Okay, 10 o'clock Eastern, 10 p.m. But I don't know. So then let's see. Dean Bustador is with us, and Becky says, "LOL, I have a summer home here in Shelburne." Okay. That's nice. Donald Kunzer's with us, and C&D Boy's with us. Otto's with us. Hey, Otto. It's nice to see everybody. So we're going to be... this is the only object we're going to look at the lower end of the Milky Way. Then we're going to continue north and capture other objects up there that are way out there. But we started at 11 because we wanted to give time for Cassiopeia and other constellations to pull out of the northeast and go a little higher in the sky. We can still see them, especially with this telescope, because this telescope is actually it can actually peek above the roof and see almost to the horizon. With the telescope, I actually looked at the train tracks a little further away. When you hear a train sometimes in the speakers, it's a train that goes, let's see, it's probably once an hour train comes through there. And they're big freights. They're big, oh gosh, they're anywhere from 1 to 5 miles long, no lie. So just imagine what happens when you're sitting at a crossing waiting for the train to go by. It just goes on and on and on and on. Now, as I said, I'm in Connecticut where the trains are a lot shorter. The telescope here, this telescope's 2,500 and change miles away. And on the Benson Plateau at 3,600 feet elevation. That's pretty nice out there. Yeah, actually very nice out there. And I'll show you the all-sky view of this telescope. This is not my all-sky camera. My all-sky is more sensitive, and the Milky Way is extremely obvious. But I'll just give you the latest view here. You can actually see the lens flare from the moon right here. Okay, and you can see the sunset light over there. We're just not quite fully dark yet. The sensitive camera can pick it up. And this little glow right here, this is the glow of the moon, which is in the southern Milky Way right now. So it's not something that is gonna be conducive to us, looking at the Milky Way, unfortunately. And to see that more directly, let's do this. Okay. So I back away here. We are right here, and this is the Milky Way. And if we move down here, you'll notice that the moon is right there. The moon's actually looking, almost at the place where the window here, Bod's window right there, that's the clearest view through dust and stuff to get to the center of the Milky Way that we have. And it's not a clear shot anyway. We only see just a little further, and not at all the way there. There's a lot of stuff in the way. Okay, so we're up here looking at the Scutum star cloud is up here, and this again is Messier 11. It's known as the Wild Duck Cluster. And to see the Wild Duck Cluster right here and the star cloud requires a dark sky. And right now, it's sort of the equivalent of a little bit of light pollution, because the moon, even though it's only a little less than first quarter, so in other words, it's not quite half lit, quote unquote, from our perspective, it's just not it's not that bright. But when you have no other lights around you, it's screamingly bright, and that's the only light that you see. Okay, so this is the Scutum star cloud. Actually, I'm gonna go right here. I'm sorry, the Messier 11. I'm gonna set the target name. Okay, I got a whole bunch of shots here. I mean, I got 85 because I started it before we started, so you guys would have something to look at as soon as you came in. All right, so we'll save these two things. Now we'll come out and we'll go back to our our low light mode here. Okay, there we are. So that's what it looks like. You can see this, it's light right here because it's lighter because we have some moonlight. Now let's go check out our planetarium program here, and let's go digging through a few things. First things first, let me bring that volume of the music down just a little. This is a globular cluster we're going to check out. What we're just looking at, that was not a globular cluster. Okay, that was not a globular cluster. But this, on the other hand, is a globular cluster, as you'll see in just a moment. Okay, so I'm going to come over here, and I'm going to move it into the center. So what I'll do first of all is let it identify, and then we're going to move it. Okay, and we'll move it into the center of the view. There we are. So that's now in the center of the view, and we will come out of here, and let's now do a 20-second photo of this object. And I'm going to start the guiding process here. Plenty of guide stars, all good ones. All right, so we're guiding now. All right, now let's come out here and let's start this. You can see that our little guides right there. You can see the progress bar. It's behind our Asterion Foundation sign. Asterion is a foundation tied in with Lowell Observatory and a bunch of other big science museums around the country. And they gave us a small grant in order to get some equipment that will be very, very beneficial to us. And we're in the process of getting that equipment now. Okay, so this globular cluster, I'll back out because you'll notice it looks a little bit red. There's two reasons for that. Number one, we have to catch up a little bit more data, right, to saturate this sensor a little more. Number one. Number two, it's a little bit red because the moonlight tends to redden our images, oddly enough. So if I pull this down a little bit, if I just drop the red a little, you see it looks a little better. Although it stays pretty red, and you'll see how our red curve is far to the left here. That's interesting. I won't be keeping this. I just wanted to show you what a globular cluster looks like versus that other cluster, which is called an open cluster, but a very, very, very compact open cluster with very, very many members. Yeah. So remember, if you have any questions, do ask them. I will be watching the chat. Andy Morrow's with us. Hey, Andy. How are things over across the pond? All right, I'm not keeping this, so I'm just going to get out. And I will do this. As you know, Ronald, ERT Radio, is someone that has been one of our founding supporters for a long time, and he has moved to Benson, Arizona. I think he wanted to be near the telescope in case something broke down. He could run out there and fix it, but I don't think we'll have to avail ourselves of him. So I think he's going to be lucking out and not having to repair anything. Telescope's doing great. Donald Kunzer has a question about a comet near Cassiopeia. I'm going to look for that because I know that there are some comets out there that we'd like to see, including, by the way, 3I Atlas. I just want you to know 3I Atlas is very likely a comet. I think it is. Everything about it seems to indicate comet. Alright. So now, I want to show you. Let's see if this works. There it is there. It's only 25 degrees up. Okay, that's still in the northeast. We got a ways to go. So we're gonna let that ruminate for a while. That was a galaxy I wanted to show you, but we'll have to look at it again. But now, right up near the zenith, we've got a lot of very, very cool things up here. Okay, this is Cygnus, the swan, right? And you can see the swan here, right? Its face and beak are Albireo, that's the end star in this northern cross. You see, it goes from Deneb to Satyr to Albireo. And then these stars are the cross stars. So basically, if you think of it that way, it's like a northern cross. See? Cool. Yeah. Yep. Now, one of the things I wanted to look at here was there's a little nebula up here that I want to check out. And it's, we did the other night, we did the Cocoon and we did Elvin's Trunk. What we didn't do is the Wizard Nebula, and I'd like to do the Wizard tonight. It'll be the first time with this telescope that we're doing the Wizard. So let's see if we can get to the Wizard without any issues. telescope is gonna do what's called a meridian flip and look toward the northeast. Alright, and we'll come out here and stop that. There we go. It's 55 degrees up, so the telescope's gonna be almost there now. Okay. Now we're gonna see how close we got. I may have to refocus, but we're gonna find out in a minute. Let's see if we can figure out where we are. Okay, so it knows where it is, so what I'm gonna do now, because I selected that, I'm gonna tell it to solve again for its location and put the Wizard Nebula dead center into view. So it found it, and now it's going to move this, and there is the Wizard Nebula right in here. And if I come over here and look at our thing here, let's do this. Okay, we're in the constellation of Cepheus, and here's the nebula we're going to look at. It's really cool, and we're not going to be able to see all of it. We're going to only be able to see a part of it, and that's actually the good part right there. Not bad. So there's red nebula throughout all of this, so let's check it out. All right, first things first, we're going to do a 30-second shot, and we're at 250 ISO, okay, sensitivity on our whatchamacallit, our sensor, and we're gonna do 30 seconds at that. So we're gonna do this now. Off we go, and I'll come out of here, and you can see our progress bar over there is on its way up. All right, and we'll be live stacking this, so this is going to be going into our deep sky mode now. And while I'm at it, I'm going to grab another star image and select our stars. There we go, and start tracking. Hopefully this one will track fine. If not, we'll do another shot. Oh, look at that. There's the wizard. Wow. That's really pretty. Now that's just with one frame. Watch how it gets so much better as soon as we get a second frame. A lot of this noise disappears. Watch. Look at that. Look how much better it got just with 2 frames. And this is that rule of thumb I told you about before. When you take a photograph of a night sky object, if you take 1 frame like this, it's great. Take 2 frames, and then the digital noise is cut in half. So every time you double the number of frames, you cut the noise in half from the previous half. So if like 4 frames are better than 2, 8 frames are better than 4, 16 frames have half the noise of 8 frames effectively. And that's kind of cool. Jessica S is with us. Hi there, Jessica. Toner says, forget what the galaxy between Cepheus and Cygnus is, but I had a fun time finding that the other night. Oh, okay. Well, while this is doing this, let's see if we can go look at what you were looking at between Cepheus and Cygnus. Well, this is Cephas or Cepheus, and Cygnus is up here. So the galaxy you were looking at, I wonder if it was directly between them. And maybe, not sure. Maybe it's it wouldn't have been this guy. Fireworks Galaxy? Was it that one? Let me know. He'll let me know. Okay. Alright, so now we're going to be back down here at the wizard. Yeah, there's all kinds of crazy objects coming up, but look at this. Here's the wizard. Let's see if we can see what else is hiding in here. We're going to overprocess for a moment. Oh yeah, look at all that extra stuff. That's crazy. Beautiful. Alright. So now I can bring this up a little. Pull out a little more details. You can see it got brighter. Alright, let's go here. Let's just do one thing now. Oops, I didn't want to do that. I want to go back here. Okay, that's where I want to be. Alright, let's see. Okay. 8 images captured right here, you can see. And we stack, you know, we're doing an image sandwich one after the other, and the more we put on top of each other, the better the images get. There's so much going on in here. This is what's really pretty. Look at that. Man, that's something. This white curve is the average of the red, green, and blue curves. So if we were to slide this up right near the top, that's about as dark as we can set the background without losing data. And that's kind of important. Yes, sir. Okay. Take off a little bit of the noise. NGC 7380 will set that target name, but I'm gonna come up change the name to Wizard Nebula, which is what it is. Excellent. All right, 12 images. We'll save them there as well. Michael Hendricks with us. Hey man, how you doing? Of course I'm taking questions, Michael. Yes, are you taking random questions? Toner says, just a faint fuzzy in my 8-inch. If you're talking about the Galaxy, was it? Oh yeah, okay, Caldwell 12, the Fireworks Galaxy. Yep. Yeah, we should check that out too while we're here. It is kind of small, but we can check it out. Maybe we'll go over there after this. You'll notice that we're getting a lot more detail in here now. There's a lot of really cool nebula in here. This is Reflection Nebula, which is just scattering blue light from the stars in this region. And then the red is hydrogen gas that's being ionized by the hot stars. And when the electrons come back into the atom after being ionized and getting kicked off the atom, as they come back in, they give off light. And the predominant light they give off is red. It's red, 65, 62 angstrom, 656 nanometers. Michael asked, did the comet change course and off gas or something? Oh, 3A Atlas. Yeah, let's talk about 3A Atlas. I've been on so many shows about 3A Atlas. It's been crazy. And that's okay. I mean, there's a lot of people wondering about it, and they should have answers to what 3A Atlas is. As far as we can tell as astronomers, we think that 3A Atlas is actually a comet. It's behaving like a comet. It's off-gassing or out-gassing, as we say, like a comet. So it's actually doing cometary things. So it looks like it's actually doing what it should do. You know? All right, I'm gonna do something here. One second. Okay, I had to fix something. Okay, so the truth is then that 3I Atlas is probably a comet. Now, one thing we've noticed is that its trajectory hasn't changed as much as we thought it might. Now, no, that doesn't mean it's a spacecraft barreling towards Earth. If you read Facebook or any of the other social media, you would think that it's heading for Earth and we're all doomed. And honestly, that's baloney, pure baloney, plain and simple. So what happened is 3A Atlas hasn't been changing course that much as far as we could tell because it's more massive than we thought. So the nucleus of the comet is probably on the larger side. It might be 25 miles across, which is it's a moderate sized comet. Some comet nuclei are very small, some comet nuclei are large, but this one's interstellar, so it's coming from a long way away, and because it's coming from so far away, it's possible that this comet is actually a comet that hasn't seen a star of late, in the last several 100 million years or longer. This thing may be 7 billion years old, so that's almost twice as old as our solar system. And if so, then it means that this guy has been flying around out there, acquiring debris and more material without ever having passed nearby a star that would then melt that stuff away, which is exactly what the passage by a star will do. So that's kind of what we think this might be, is a very large comet that has come in. It's sort of it's a perfect place for us to land on if we could actually ever figure that out. But it's coming in so fast that I don't think that even if we had the capability that we can actually, the capability to reach it, I don't think we can actually do it. Really cool though. Yeah. So, yeah, look at this. This is looking beautiful now. Looking really nice. I like it. Lots of detail in this nebula. I haven't seen it, with this telescope. This is the first time. Very first time we looked at it here. And sometimes if you make them really small, you can see more details better. Notice this big faint thing here. That's something we've never seen before. Let's see if I can pull some of that out. Wow, look at that, huh? That's neat. Interesting stuff. Okay, well, I'm gonna... I spelled wizard wrong. I'm gonna go up here and... There we are. Okay, now we'll save it. Okay. Now, if anyone wants it, all you have to do is go to skytourlive.org, scroll down, and where it says, I want cool pictures, read the instructions, and you can go grab this, because it's probably, as we speak, getting uploaded via satellite to our server, beamed out of the desert and sent to our server. Pretty cool. Donald Kunzer says, its best chance to turn towards us is when it gets to Mars and does a gravity assist pivot. Yeah, I think that's probably true, but you got to remember that the solar system's in 3 dimensions, and where Mars is and the Earth is at the time, any subtle deviation to the trajectory caused by Mars has already been calculated, and it's going to be over 170 million miles from us at its closest approach. Right now, it's gone. By the time the sun sets, it's setting right after the sun. So it's pretty, unfortunately, not something we're going to be able to see right now. And hopefully, if there's another chance to see it on the backside of the sun, maybe we will. Hey there, Maj. How are you? Nice to see you. Welcome to Sky Tour Livestream. Yeah, that's a good point. I had the music up a little loud. My mistake. Okay. And I wasn't planning on doing a lot of talking, but okay. Okay, we're going to do this. All right. So that'll be up there to check out. All right, let's go back to, let's grab something else. I think we talked about maybe doing that fireworks galaxy, so maybe we should try that. I'm going to bring this up bigger here. Let's go to our planetarium, back away, and what's this guy here? Oh, it's a little planetary. Well, it's on its way. It's on the way to the fireworks galaxy. So I think we should maybe look at that too. Okay. All right. We'll try that. What's over here? What's that one? Yeah, no. We're going to look over here at this planetary nebula. Planetary nebulae are interesting because they're the remnants of stars that have died. And when they're planetary nebulae, it's stars that are kind of like the sun. So stars that don't have a lot of mass to them. And so when they use up all their hydrogen, they swell up into giant stars that are red giants. And so what's better is for us to consider how when stars use up their hydrogen and they swell, we consider what happens when they are done doing any nuclear fusion processes. They begin to shrink. And when they shrink to, in our case, the sun's case, and stars like the sun, into what's called a white dwarf. White dwarfs are special types of stars that are no longer fusing anything. They're just a hot, compressed remnant of the core, made up mostly of most times, carbon and oxygen nuclei, and free electrons, all packed so tightly together that it can't be crushed anymore. Make it more massive, on the other hand, and it could continue to shrink down and become a neutron star, which is even smaller. A white dwarf is about the size of our planet Earth, and a neutron star is about the size of Manhattan Island. So I think that is pretty interesting. So let's see if we can move over to this planetary nebula right now. I believe that's it right there. That's going to be a real pretty shot for us. All right. Now, what we're going to do is we're going to first of all get our guiding set. There we go. All right. Now you can see this planetary nebula. What it is, it's a halo, a spherical gas cloud that was expelled from the star in the middle. Now, we don't see the star in the middle. I've never looked at this object with this telescope, so we're going to find out. I'm only going to do a 15-second photo because I'm going to guess that that envelope is going to be pretty bright. So I'm going to try and figure out if I can catch it just a little bit dimmer so we could see what might be going on in there. Let's see. Yeah. Alright, so I'm going to pull our black level back. Okay. Gonna do this, drop that down. You can already start to see detail on there. Oh, this is a really pretty nebula. Let's see if it knows it. It does. I gotta align it. There we go. That'll be our target name. Just beautiful, just beautiful. I'll change this to a PN for Planetary Nebula. So the fate of our sun is that someday our sun will be a ball of gas like this left behind. I'll save that with annotations too. Okay. Now, when we look at this guy, you'll notice that it has a, let me color correct it too. You'll notice it has a interesting color to it. It's blue, isn't it? It's sort of like this teal blue. That's the color with hydrogen. We know the hydrogen glows red when it gets ionized. And then this is oxygen. Oxygen glows teal when it ionizes, and that's what we're looking at here, is ionized oxygen. And doubly ionized, so we have two electrons that have bounced off the oxygen atom, and when they recombine, they give off this characteristic teal light. That's something, huh? Look at all the detail in it. It's got extra shells out here. You got a really sharp shell in the middle here. You know? Really sharp. That's neat. Wait, let a couple more. So, right there, you can see there's like a little shell. There's a sharper shell in there than outside. You've got this fuzzier outside. There's also some stuff sticking off here at this side. You can see this stuff sticking off right there. Now, we don't know what that is yet, but we're going to zoom in on that a little bit more and see what that is. Oh, look at that. Now, that's cool. Yeah, so we can now see actually that there's more detail showing up in this envelope. You can see this shape right here, that darker elongated center. That gives rise to a thought process that maybe we're looking at something that maybe in some way what's called bipolar, where you have two lobes on each side. The Dumbbell Nebula that we look at, it's like an hourglass, right? An apple core, okay? That's bipolar. In other words, there's material that is coming off of it in one direction or another, symmetrically to both sides. And this strange little line right here, if this was just a straightforward sphere and going evenly in all directions, this would just be sort of a round center like the Ring Nebula, but it's not. You know. Hey, Gentle Rain, how are you? Nice to see you. Laura Newbert, how are you? Nice to see you as well. Laura says, what will happen if today's M6 solar flare with CME hits Atlas as predicted? Not much. Atlas is still out by Jupiter, 3i Atlas. So the intensity falls off with the distance, so it's not going to be that big a deal out there. Maybe if the solar wind is heightened, it may outgas more material. You might see maybe the coma, the fuzz around the nucleus might get a little bit larger. But other than that, the solar flare, even an X-class flare, which are the strongest, even an X-class wouldn't do much damage to 3i Atlas. If it got closer, however, if it was on its way around the sun at that time, then maybe it could do some significant damage to it. But right now, no, I don't see any of that right now. Gentle Rain says it looks like an eye. It actually does, doesn't it? Let's see if we can zoom in a little bit more. Okay, now as we get closer, we're going to get too close, obviously, for comfort. But you can see now that softer outer layer and then a sharper inner layer. That's not an artifact of the telescope. That's actually what's really there. So this is neat. And it kind of looks like an eye. Lewis is with us. Hey, Lewis, how you doing? Yeah, Lewis says, some of my New Age friends are saying that 3i Atlas is actually a UFO. Yeah, I know. That's what they say. But the fact is, it's not. It's pretty clear that if it was a UFO, it's a UFO that's being disguised as a comet in a very, very convincing manner. But, I am open-minded. I know Avi Loeb, who you guys know. I've worked with Avi. I know Avi. I worked with him on TV programs. Avi is saying that we can't ignore the possibility that this could be a, extraterrestrial craft. And he says that because there's a 0.005% chance that something coming into our solar system would actually come in at the trajectory it did. It's coming in along the plane of our solar system. So the planets are in a plane. It's coming in along that plane. And that's not expected. That's kind of rare, actually. So that said, it's going to pass Jupiter, which is the largest planet, second largest gravity in the solar system, next to the sun. Then it's going to pass Mars. And it's going to be on this hyperbolic trajectory, which means it's not going to be held by our sun. It's going to curve right on through the solar system and keep on going back out into deep space after a brief visit with our sun. And it's going to pass by Venus on the way out a little bit. And we say pass by, we don't mean it's going to go, woo, it almost hit. No. Millions and millions of miles away from all of these planets. Our planet is going to be 174 million miles away from us at its closest. So we're talking about, it might be a somewhat spectacular object in the sky. We're going to look for it if we can see it, Let me look and see. We got questions here. Donald Kunzer says, I thought of the idea of using a large asteroid as a spaceship. It would have a covering of ice that would thaw and become an atmosphere as the ship got closer to a star. Well, yeah, that's true. You're not the first one to think of that, though. Science fiction beat you to it. In fact, Star Trek beat you to it. In fact, the episode was called For the World is Hollow and I Have Touched the Sky. Long name, but that was the name of it. And it was about a people that lived inside of an asteroid and didn't know it. The sky was a pink without any detail in it. And it was the inside sphere of this asteroid. And the asteroid was hollowed out for the people living inside of it. Pretty cool. Yeah. Gentle Rain says, well, we've had Borisov and Oumuamua in the last handful of years. It gives the vibes it's throwing stuff in a direction for our attention. Well, for attention. I understand that thought. And is it possible? I'd be, arrogant to say absolutely not. But I don't think that it's something that... I don't believe it's something that we have to worry about. It's not an object that's going to be approaching us really in any way. It's not going to be getting close to us. Let me just drop that. See if we can get a little more detail out of this. Look at that, huh? You start to see this really intense shell here, and this outer shell. That's neat. Donald Kunzer, the Planetary Travel Agency. Good call. Good thinking. Okay, we're gonna save this guy where it is. Alright, and then we saved it. Now we're gonna come out and go back to our low light mode. You'll see this in the low light mode. There it is. Now let's come back here and let's do the Fireworks Galaxy. Sort of along the way. Okay. So here we go. Okay. And let's zoom out and see if we've caught the Fireworks Galaxy. I think we may have. Let's find out. Let me see if we've got it here. That's 6939. 6946, or Caldwell 12, as we heard earlier. Okay, well, all right. Let me come over here. Yeah, 6939 is this guy. And we would actually be heading up more. Okay, well, you know what I'm going to do? I am going to tell it to go to the Fireworks Galaxy. Alright, and we're going to plate solve and resync. And the Fireworks Galaxy will be dead center in a moment. We'll see these things go down here. All right. Yeah, I know. I got my... There it is. So it's dead center now. Okay. And now what we'll do is come back and get our guide star ready. Alright, so we'll stop this. Reset. Get a star. Here we go. Beautiful star too. Alright. Fireworks Galaxy is right here. And so what we're going to do is we're just going to do a 30-second shot of this because it's going to be somewhat faint. But we're going to try it. Don't you know? Why not? Okay. And we're going to come back in now. Go into our live stack so we can start building an image sandwich. Are you guys having a good time tonight? James Dugan's with us. Hey, James. How are you? How are things down in Australia? There's the Fireworks Galaxy. Oh, that's pretty. Look at that. Look at that. Really nice. Okay. James, I'm still trying to find a site down there to actually put a telescope in the southern hemisphere. We gotta do that. Okay, so now I'm gonna move this mid-range thing out just to get rid of some of the noise. There you go. We can see some details in here now too. Look at that. Neat. Tornillo says, if I understand correctly, this one is famous for nova activity. Is that something we could see with a scope like this? Oh, absolutely. We've seen a nova occur in. I think we saw that in this galaxy actually. But we had it in other galaxies. We actually see them in other galaxies as well. This scope sees us very nicely. But this is the Fireworks Galaxy right here. Let's okay, it's it extends us right there. I'll save with annotations even though it goes outside the boundary. Gosh, that's beautiful. Oh, and you know what? I'll set our target name too. Yeah. Okay. Alright, that's looking good. And the more images we take, the better it gets, as I mentioned. We're at 4 images, so we have half the noise of 2 images, effectively. It really looks nice. So you double the images to cut the noise in half. And as soon as you start cutting the noise in half, you can now take this guy, this mid-level guy, and move it in a little bit to start brightening the image. See if I go too far, watch. Right? See how noisy it is? It's really noisy in there. So that's trying to go too far for the processing that was done. So we'll back off just a little and let the image catch up. Oh yeah, nice detail in here. I did do a critical focus, by the way. I did that before. James Dugan says, "G'day, Mark. Going great, mate. Summer is on the way." Yes, it is, sir. And our summer is waning. But that's the way it works. Don't tell the flat earthers. Lots of great nebulas down here to check out, Mark. Yeah, James, I know. Yeah. And you know what? I'm a wizard of the northern hemisphere sky. Put me in the southern hemisphere and I'm like, whoa, what's that? I don't know. Spock, I don't know what this is. I have to figure this out. Scotty, get us out of here. That's beautiful. Look at that galaxy. Wow. That's really nice, isn't it, guys? That's really nice. Seeing as we get another image, you watch it'll get even better. So there's 9. And if we look at our full width half maximum filter, you can see that I can bring this down. This is the threshold. If the wind hits us, we want to have that threshold down low so we can reject that frame automatically. But if I miss it, I can always click unstack and it will take that last one away. Look at that. Beautiful, beautiful stuff. Yeah. Yeah, and this is at 250 gain. That's very important, you know, getting the gain right. You know? We need to have the gain correct. If we don't use the right gain, then it's going to be a big problem. So for instance, okay, over here, the exposure is one of the main factors here, but then the gain is the other one here. Okay, this is how long we're going to expose it, and then this is how long or how sensitive we're going to make that sensor that we're exposing onto. Okay, this is the telescope view 1, this is view 2, this is our telescope stuff there. Sorry about that. Okay, and stop. It's going crazy. And this is our stacking frame, our stacking window right here. And of course, this is yours truly. Yep. Okay, so that's enough of that. But good. Okay. Yeah, Fireworks Galaxy is showing blue. You see the blue in the spiral arms? That's beautiful. Now we have a nearly first quarter moon out. And the fact that we're seeing this shows that we're really able to pull a lot out with our filter. That we're using what's called over there on the right, you see it where my cursor is. It's the UHCS. I have an SA100, which is a spectral filter. We can look at the spectra of the stars there. We have a radiant filter, which is sort of like a narrow band. That would be used during, say, a full moon to look at a nebula. Then we have a dark frame, which means a disc that covers the whole, so we can't get any light in. That allows us to measure the dark current coming to our camera. And then this is open, so we would just see the sky for as bright as it is. Neat. Okay. So 14 images so far. We're starting to see some detail in here. Look at this beautiful, this is like a nebula in here. See that reddish color? That's nice. And then we have this blue spiral arm here. Donald Kunzer, I think you mentioned earlier, it looks like a loose spiral. I'm going to guess this is an SC spiral, which is S for spiral and C. And it is Fireworks Galaxy. Oh, how about that? It's a barred spiral. I guess it is, because this is the bar in here. Okay, but it is a loose spiral. Interesting. It's a special spiral too. Yeah, see, it's not even galaxy season. We see one of the best galaxies in the sky. Let's go right to the peak here. Let's pull this in just a tad. Look at the difference. Look at how much more data we can see now. I'm going to come over here to this guy and over on the right there, and I'm going to over process, right? And like this. Okay, look at that. And then I'm going to do this. I'm going to invert it. So now you can see the spiral structure very clearly. See that? And it also helps if we remove the color so it looks like a black and white image. This is traditionally what we in astronomy would look for. We would look at the inverted images because those show us a lot of detail. Here we can count the spiral arms very easily, whereas in the non-inverted version, we couldn't, right? And so it's harder to count them here, but when we're inverted, we can. And I over contrasted it there just because if we do it this way, you'll see that the spiral arms don't really show up much here. So we actually really over process it to show those spiral arms. And that's what we did. Okay, we got 19. I'm going to go to 20. Oh, the galaxy is beautiful. Wow. let's talk about the fireworks galaxy a little bit. William Herschel found this galaxy, okay, in 1798, and it's actually at a distance from us of about 21 million light years, and that's a pretty good distance, considering that the Andromeda galaxy is 2.3 million light years, right? And this is literally more than 10 times further than that. But we can see the data in there. We can see the dark line. You can see the dark lanes and dark detail in here. It's really pretty. And then being at a distance, as I said, of 20 million light years away, this guy is pretty large, actually, to show its size like this and in the view. Some galaxies are tiny little things you can barely see, even in this telescope. But this is nice. Very, very nice. Gentle Rain says, I'd throw, I'm almost at Bitcoin. I'd throw a BTC to own a scope like this. The red dot in the center of the galaxy, as asked by Lewis, is the nucleus of the galaxy. And the galaxy is, again, the moonlight is messing with our image a little bit. If I were to do this, you'll see that it has a red cast. It doesn't really. So I was actually dropping the blue level down significantly to show what it really looks like. So this is about what it looks like right here. But in place of that red nucleus, it's going to be more yellow. All right. But that's kind of what it looks like. That's nice. Wow. I know, I keep saying that. Let's see if we can zoom in a little. You can see here, this is an area of star formation. Really, really beautiful. Under enhancement, I don't have an unsharp mask on. If I turn it on, it might get a little noisy. Let's try it. Yeah, it's too noisy. So we'll turn it off. And actually, we might even want to do a bilateral filter right here. Or not that. Maybe. Okay, well, I was going to try some type of blur, but we're good. Yeah, that's something. And I know. Let's try this now. I'm going to pull this level down a bit. Okay. And then zoom in. All right, so now you can see this is an area of star formation going on in here. This is one of the spiral arms. You can see it's here too. And again, the blue is hot young stars forming in the spiral arms. Okay. Here is a very turbulent region. This is actually a very hot young group of stars called an OB association for spectral class O and spectral class B stars, which are hot and blue. Ronald says, what size scope is this, and why did you opt for the scope and not a Schmidt camera? We can do more with a telescope than with a Schmidt camera. And Schmidt cameras are extremely expensive, and this telescope was not considering what it does and what we're doing with it. Plus, it's more versatile. We're doing more with this scope than we would normally. This is the Benson scope. It's a narrow field system. The telescope in the Sonoran Desert is a wide field system. So if we look at the fireworks galaxy, it would only be about this big in there. Okay, so we're seeing all this detail that we wouldn't really get to see. You know, all this, look at that beautiful, knotty, dark material in there, which is now showing up with 29 frames we've fired up. Look at that. That's something. All right, we're going to go to 30 and then save this. I want to thank you, by the way, for, I think it was it you, Toner, that talked about this? Thank you for mentioning it, because it was really a worthy target tonight. Thank you so much. Okay, and then we'll save it exactly as seen. Becky says, it looks like it's spiraling clockwise, and if so, why? Well, if you looked at it from the other side, it'd be spiraling counterclockwise. It just happens to be the direction we're looking at it. If it was flipped over, it'd be going the other way to your eye. So that's just a convenience that we've created. But the spiral structure, that's actually a good point, Becky. I'll bring that up. Okay, you'll notice that these arms sort of trail behind. The galaxy is spinning this way. Okay, and so the arms are trailing behind because the stuff out here is moving slightly slower than the stuff in here. Now, this galaxy's been around for billions of years. So you might say, but wait, if it's been winding up all these years, wouldn't it be all wound up already? Why do we see such loose spiral arms? And the answer to that is a solution that was a puzzle to us in astronomy for a very long time. And the answer to why the galaxy looks this way and why the spiral arms look that way, loose like this, is because the galaxy, even though it has some differential rotation, meaning the outer stuff's a little bit slower orbiting than the inner stuff, okay, even so, it's not as much as it should have. When you look at Mercury going around the sun, it goes around the sun. It's the closest planet to the sun, and it goes around the sun once every 88 days. Wow. Pluto's like over 250 years or so to go around the sun. It's slow and lazy out there. So over 200 years for Pluto. Mercury, 88 days. So you'd think that these stars in here would go whipping around this nucleus very quickly. But the stars out here would go very, very slow. And not as slow as we might think, Becky. And the reason is because there was something that was helping the stars move along out here as they were orbiting the galaxy. And all stars orbit the galaxy. And that helper, if you will, was something that we discovered. It's called dark matter. And dark matter is responsible for keeping the rotation of the galaxy acting almost like a rigid disk, although not a rigid disk. Almost like a rigid disk. So, okay, there we go, we got that. All right. Okay, so let me just move the camera here. Actually, I'll show you what's going on. If we look down in the building right up above there, you can see the telescope here. Let me move this down a little. Okay, the telescope is sitting on a pier that's 63 inches tall. Okay. And that's actually, then over here on the side, down below, we have equipment here, which runs a telescope. A lot of stuff over here. And then up there is our open roof. This roof rolls on and off of the building, and it comes from this side and rolls on over there. Okay, so that's how this works. Same thing in the Sonoran Desert. That one does the same thing. It's just not as high a set of walls. All right, let's go look at our all sky briefly while we get some final shots here. Okay, now let's refresh because it doesn't auto refresh like ours does. Oh, good. You can see the Milky Way. Okay. Sensitive this. Now you can see some soft lights from distant lights in the distance here. That's a very soft glow. You can't see that with your eye. Yeah, this location is marginally darker than our Sonoran Desert location. Okay. That's beautiful. Wow. I'll have fun processing that one. Alright, Fireworks Galaxy. Yeehaw. Alright. Okay, so next question coming in. We have... Donald Kunzer says, Mark, I'm just curious. Do you use Mac or PC-based computers? I use a PC. The Benson telescope camera, computer is this big. It's a tiny mini computer that I've adapted to use out there, and we're converting the Sonoran Desert telescope to one of those small mini computers as well. In fact, the Sonoran telescope's not functional right now because I think the computer's hung, and I need to be able to get at it and do stuff. So I'm working on a process to manage the power supply to the building. Okay, so now it's coming here, and let's back out. Now, in the time that we did this, okay, we have been able to, I believe, there's Vega. Okay, let's go to the Ring Nebula here. It's another planetary nebula. Ring Nebulas, I have found the Ring Nebula to not be that impressive in many telescopes, and I can't tell you why. I just think that because it's maybe so small, but we'll see. Okay, the telescope's doing a peer flip right now. You can see it flipping right there. And then it's going to be looking up at Vega. Okay. Actually, Lyra, the constellation Lyra. And let's see where we are. Okay, so what I'll do is I'm going to do this again. I'm going to have the telescope tell us where we are and move to Messier 57, which is the Ring Nebula. And there it is. Oh, that's beautiful. In this telescope, it's really nice. You can even see the central star. This is an example of one of those things where a star expanded into a red giant star and then shrunk back down, but as it did, it was puffing off its outer layers, just like with that other planetary nebula we saw. You notice similarly we see this teal blue color again. Hydrogen is the most plentiful element in the universe. Helium is next. Okay, and then what's next? Oxygen. Oxygen is the third most common element in the universe, followed by carbon. Okay, so hydrogen and oxygen, okay, are the two that ionize, and we see those colors the most. So we see red from hydrogen, and we see the teal from oxygen. So let's do this. Let's first of all, let me guide on this. Let's grab our stars here. Let's grab a set of guide stars. We're going to get some here. That's good. Okay. And now we'll come off of this, and we're going to do we're only going to do a 12-second shot because this is a very bright object. And so we'll come out and go into our deep sky mode, and we're going to start to see this. Now, we may not see the central star with only 12 seconds, but we'll try it. As you can see, it's very bright. Okay, there we go. And then let's set these values. Okay, this guy is going to go way down. Oh, we can't see the central star. Look at that. How nice. And I'm going to bring this up. Okay, now watch. We're going to come down here now and take this guy way down. And we can start to see some detail in here. Now, 2 of our frames were rejected. And I see why. Okay. Okay, we should start taking frames now. I had set the threshold too low. Alright, well, a little higher. Yeah, that central star is showing nicely there. It's only 2 frames. Let's see if we get more. Oh, come on. Alright, well, you're going to have to come back down. Might be getting some wind. Yeah, there we go. Yeah, so this, again, there's theories about why this looks the way it does. I have my own theory, and I'm telling you, I heard a theory. They said, oh, you're looking down a barrel of nebula. Well, that's pretty convenient that we're looking straight down a barrel. What are the chances that we'd be looking straight down a barrel of nebula here? I don't think they're very high. I have another idea about why we're seeing what we're seeing. Okay, and that has to do with this open area here, this seemingly open area in the middle here. See, here's what I think's happening. I think we're looking at a spherical nebula, okay? And on the ends like this, the front and back of the nebula, you can see through my fingers. But as I move to the side, you can't see through my fingers. So that corresponds to these areas here that are thicker along the edge. All right? That's what I think's going on. So when we see this is around the corners on the edges. So no matter what direction you look at this from, it's going to look like a sphere like this. It's going to look like a round donut with a donut hole in the middle. That's my theory. I think that's what we're looking at here. I'll go to bat for any. I'm down for the count with that one because I do believe it's true. Okay, let me come down here now even further. Let's take this and move it even further down. Okay. So now you can see some subtle detail along the outside edges. And as you'll notice, playing with this stuff is really important. Let me see if we can see the outer red fringe. I don't know if we can. No, we can't. But what we do see right here is a faint galaxy, by the way. There's a faint galaxy in this image. Yeah, it's pretty. So this is the Ring Nebula. Obviously named way for a very good reason. This galaxy is called IC 1296. It's a very faint galaxy. And it's only a few arc minutes from this thing. Yeah, so we'll save with the annotations here. After I set the target name. Alright, there we go. Okay. Alright, 18 images. Very good, very good. Let's see if we can pull this in now a little more. Well, it seems to support it, but we're losing. So this is starting to tend toward white now, almost. But that's how bright this is. This envelope. And Tony Lowe is correct. There's a white dwarf in the middle. That's what we're talking about. Now, white dwarf is so hot. Okay, just so you know, the white dwarf is actually ionizing the oxygen in the cloud of gas out here, and it's ionizing the hydrogen and neon and other elements that will glow red as well. So that white dwarf can be very hot, 20, 30,000 Kelvin, which is over 20 or 30,000 Celsius. Really, really hot. Yeah, and then we have that little faint galaxy, which is starting to actually come in right now, believe it or not. It's kind of funny. Cool. It's a beautiful night out in Benson at the Benson Telescope. Temperature in the building out there is 23 Celsius, 23.6 Celsius. So it's pretty warm. Nicely, it's comfortable out there. Yeah, all right, we got 27 here. That's where we'll stop this guy. Again, this will be available to you up at skytourlive.org in about 30 seconds. Okay. Let's move to something else. Yeah, the Ring Nebula is beautiful. So back in our planetarium, we are at the ring here. And let's see. Yeah, this is the famous M13 globular cluster. It's kind of low. Okay, I heard something moving out in my shipping area, which is not good. We had a little wind out there just blowing things around. Okay. I'm talking about in Benson. Okay. Let's wait on that because it's going to be a little too close. Alright. Now, let's see what else we can look at while we're over here. We can look at the iris. You may have seen me put this up the other night. That's really pretty. Let's check that out. Alright, just not quite right there. Yeah, we're good. Okay, I halted it for a moment because I wasn't sure, but I think we're good. It's gonna make a little adjustment. All right, and let's do this now. Let's go and. All right, let's see here. Figure out where we are. Yeah, okay. Okay. We're going to move now to put the iris in the middle. Here we go. You'll notice it looks a little fuzzy. There's a reason for that. So I want you to check this out. Now we're going to do a 35-second shot here. First thing I'm going to do, though, is bring in some stars and grab our guide stars. There we are. And start guiding. All right, we're guiding. So now we're going to do a 35-second photo. You can see the progress bar down here in yellow moving across. It's going to meet up with the Styrian Foundation's banner. And we're going to come in here now to our live stack. I was looking at this one the other day, and a mouse appeared right in front of the camera, looking at it like, hey, what's that? You know? Okay. Let's get out of there. Yeah, look at that. So this is a beautiful nebula. And I have to figure out why it's doing that. Yeah, it should be finding it with no problem. Let's try just one more time. Okay. Okay, now we're looking at the Iris Nebula is a starry area with one star. It's hidden inside a dust cloud, and when that star winked on and went nuclear, basically, the star began to light up this dust. This is surrounded by dust, but you also have some subtle reds here and there. Those are actually brown colors. If we look at them with more detail, they're actually brown, and those browns are the dust itself being illuminated. All right. And if I come over here with this and darken it up, all right, you can see that this is going to be a really dusty shot, because you're going to have dust throughout this whole image. It's really impressive. Mr. Django, what's up? That's Stephen Sept. How are you? Oh yes, sorry. I didn't mention. I thought I mentioned Celsius. 23.6 Celsius. Thought I had. Okay, I grabbed a different guide star. Yeah, see this? So now we're 5 in, and you can see some really interesting details in here. I'm going to pull some out for you. Okay, first of all, let's do what's called a push. All right, now you'll see out here this very subtle shape right here. And all the rest of this here, this is dust. All this is dust blocking the view of the distant stars. There's a little hole here and a little hole here through which you can see through the dust. And when you look through the dust, you see the number of stars in the background. This is pretty even throughout the whole image. Right? This background is how many stars there are back there. But you can't really see them because the dust is obscuring your view. This, what looks like a reddish brown here, that's all dust. So if we color correct a little better, you'll notice that this color is now a little more brown. And if we were to take this and move it out or move it forward a little more, you can see more of that dust. See that? Very cool. Yeah. And now you start to see some of the rays coming off the dust. It's really just an area where there's just so much of this material that came from supernovae and red giant stars that produce dust in their outer atmospheres, that it just ended up making just an incredible region of space. And so that one star in there is responsible for lighting up all this. And it's not a star that's ionizing all kinds of hydrogen. It's actually a star that's actually lighting up just the dust in the region. It's really something. So if we come down and bring it down here, if I shrink it down in size, you can kind of see the extent of the dust when it's smaller. See that? It's a little trick we use. You can see how far the dust goes. It fills this entire view, except for that little spot. Now we can actually increase the contrast there a little bit so you can see that better. So I'll pull that up. There you go. Now you can see that better. Now as we move in, now look, you can really see this with detail at the edges. Look at that. So that's a hole looking through it to a window of the stars beyond, like here. Okay. Now it's amazing because this nebula has been here for hundreds of thousands of years, maybe a million years, maybe a little over. But it's really interesting to watch the changes that may occur in some of these sites. Now, in this object, we don't see a whole lot of change, but in a nebula that we'll see in the winter coming up, Hubble's Variable Nebula, over the course of a couple days, we can watch that nebula change. Because it's a variable nebula, the brightness changes because it's inside a dark cloud. Like this is dark dust in here. Other than that, that's a hole we're looking through. And there's a star inside that's having dust pass in front of it as it orbits the star. And as it does so, it casts a shadow on the nebula. And so over a period of just a few days, we can actually watch the nebula get brighter and change the pattern on it. It's like looking at shadow dancers on the wall, but the wall is the nebula, and the shadow dancers are the dust going around the star. Very interesting stuff. Spared no expense. Yeah. So a dozen frames here. Let's see if we can do an identification. Let's see if it will solve it properly. There we go. Save it with annotations. And set the target name. We'll set this to be the target name right there. Yeah, I know. Okay. And then we're going to save it. And save as it's seen. I will be out here at the telescope maybe by the end of next month and do some maintenance. Oh, guess that was just a little louder than I expected. And we're gonna change over the other telescope to this type of mount. We have a second mount for it already, and that was one we bought a long time ago. Actually, when we first started the observatory, we bought the other mount knowing we were going to change to this type of mount that we see, right here. Okay, that's called a German equatorial mount. We're going to change to that mount for the Sonoran telescope as well. Okay, 15 shots. Save that. That's good. All right. Okay, so let's just zoom in a little bit on this. Very nice. You can see that hole very clearly now. All right. Okay. We're going to stop at 15 here and move on. Alrighty. And let's do that. Again, in our low light mode, you can only get a very gentle hint of the wispy nature of this region. Okay. Now, there's something else I want to grab here if I can. No. Yes. I believe this is one that we can look at. I believe we can. We'll watch our STLS marker show up here. There we go. All right, let's see if we're there. I'm just gonna have it try this and go there. We're close. All right, now I'm gonna come back here, center up, zoom in. So we're looking at a dark nebula here. All right, and that dark nebula. There are those two stars we saw in there. Okay. Even with the moon out, the moon's very low on the horizon right now, but let's try this. Let's do a 30-second shot here and see if we can capture this dark nebula here. Oh, I'm hearing wind out there. Can you hear that? There's wind coming through. We're getting some wind now. You can see some things whipping around in there. Probably should get our guide star though. So let's do this. This first one may not be that good. Yeah. Okay, this will be a good guide. Okay. It's a very, very busy region of the night sky here. We're seeing part of the nebula here. Part of this dark cloud. I've never looked at this before with this telescope, so... yeah, we're only seeing part of it. We're seeing this right here. That's right here. Let's do this. Alright, let's come back in and do some modification. Let's pull this back off the peak. Here we go. Very nice. Notice it's all red. Well, that's the red nebula color. Let's see if we can color correct that a little bit. There we go. Interesting. Meanwhile, I want to find something else I'd like to go see. This is entirely the whole region, entire region of all this. Okay, just amazing stuff. All right, this is Tie Nebula. That's another planetary nebula. I bet you that would be fun to look at too. Yeah. Cepheus. Hey, good vibes. How you doing? Hey, Sally Forth. How are you? Sally Forth saw her favorite band. Oh, I'm glad you went to see your favorite band. I imagine it was a good concert. Okay. I may abort this. Let me see if it understands it. It may not. I'll just add it in here. Okay. We have 7. I'll save it with 7. Just to have a record of it. I'm not looking at anything fancy. To me, I could sit here and let it do a lot more, but I'm not gonna. All right, let's move on to the bow tie. I think could be more interesting, but we'll find out, won't we? Okay. Okay, there's the bow tie. Oh, look at that. That's going to be nice. All right, we'll check that out. I had a feeling this one was going to be better. All right, let's get our... Well, let me move it in first. I got to move it in. Okay, I'm moving in. Hey, come on. You went the wrong way. Here we are. Okay. Wow. That's going to be a neat planetary nebula. This is going to be different from the others that we're looking at, because in this particular case, we're seeing that we don't have the same teal blue, do we? We actually have a red color. And that's because this particular planetary is actually expelling more of a hydrogen envelope that's being ionized by that white dwarf, which is right there, than by something else. Okay, let's grab a star field. Let's grab some stars. And let's go to the races. All right, here we go. Now, this is a very bright nebula, so I'm going to drop this to 200, the sensitivity, and we're going to make the exposure here 20 seconds. And that might be too bright, but let's see. So off it goes. It's doing its thing. Let's go into our deep sky mode. Hey, good vibes. Not to worry about being late. You're cool. It's all right. It's good to see you. All right, let's see what we got. Oh, look at that. Wow. Yeah. Definitely a bipolar nebula. This one has you can see it has this extension off the top and the bottom. Okay, and let me actually do a color correction here. And now that the moon is nearly set, we are getting our proper coloring now. Look at that. Okay. We're going to move this as far up as we can go. And then move this down because we can't support that kind of view yet. Look at this thing. This is beautiful. Okay, let's... and you can see it's called a bow tie for a reason. Alright. Look at that. Wow. And we can already start to zoom in because it's so bright. And you can see the bow tie, right? It's neat. And let's overprocess for a moment to see what else is there. As you can see, it definitely has a vertical component like this to go along with its sphericity, spherical nature. And the white dwarf is actually pretty energetic. Wow, it's nice. I mean, it's even... I gotta bring this down even more so we can see some detail in here. Yeah, you can see now there's some real subtle detail in here and here. That's really incredible. That's nice. Wow. I like that. I like that a lot. I've never taken a picture of the bow tie with this telescope before. Hey, Pra, what's going on? Ronald, who's radio, asks, could it depend on the age of the star? Talking about the color. It depends entirely what the star is made of originally. And the age of the star wouldn't matter because if it's leaving a nebula like this, it's already at the age where it's finished its hydrogen fusion and moved on to the next stage of its evolution. You'll notice around the edge here, it looks like we got little bluish color in here, maybe some here, I'm not sure. Let's see if we can support doing this now. A little more deep processing here. You can see there is definitely a colorful rim right here. Let me actually take the colors down a little. All right, here are the colors at 50%. Because it was just almost too gaudy. Now, in the past, we would always take pictures here in black and white. But you can't tell what's red and what might be blue in this picture. The only way you could do it is by using film that has a sensitivity to red or to blue. And then seeing in which one was it brighter. Neat. This is really something. Holy cow. We'll save this like this. Our last object is going to be another galaxy, just so you know. And I know you want the Andromeda Galaxy, but the Andromeda Galaxy, I would need to do a mosaic to capture all of the Andromeda Galaxy. Even in the wide field scope, I have to do a mosaic to capture the whole Andromeda Galaxy. In this one, I've got to do, in that one, I had to do like 2 shots to capture in the Sonoran telescope. Wide field, I have to do 2 shots to capture the Andromeda Galaxy as a whole, with wide field, multiple degrees, per field. With this one, on the other hand, I would have to do to capture the Andromeda Galaxy, I'd have to do about 6 frames. About 6 frames overlapped. Okay, so that's pretty neat. Amazing there's something that red out there, isn't there? That's cool. Yeah. Yep. Okay, 17 frames. I'll save it again. Keep hearing something on my shipping area. May have a mouse out there knocking things down. Earth Radio, Ronald says, you did a mosaic of Andromeda for me. That's right. You had a... Ronald got a private stream. No, not private. He was on with us. He came on with us. He made a significant donation, and that was very kind of him. Yeah, this is something else. We're starting to see a lot of detail now in this. Look at that. All right, you know what I'm going to do? I'm going to add an unsharp mask now. Watch this. Let's see if we can see more detail. Oh, yeah. Look at that detail popping out of there now. Wow. That's cool. Yeah, the unsharp mask has really done wonders for us here. I like it. All right, 21 frames. Let's see. I'm going to overprocess again to see if there's anything in there we might miss. There seems to be something here. See that? Let's go back here and bring this in more. Yeah, see, look, there's a red tuft here of some kind. It might be associated with this, I'm not sure. I don't know. Oh, okay. Let's color correct it one more time. Good. Let's pull this dark value almost to the peak. makes it about as dark as we can get it without losing data. Now, in like a tiny telescope, you might see it looking kind of like a square, almost like that. But in a bigger telescope that's doing a time exposure like ours, we might get something very different like this. Boy, that's nice. That's 26. Okay. Alrighty. So there we go. The Tie Nebula. Yeah, I know. Cool name. And it's saved. It'll be up at skytourlive.org. Go grab it if you want. And now what we'll do is come in here and remember to take this off right now. And now come here. And let's now go. Let's go here. It's Polaris right there. Oh my. I guess we could. We're on the correct side. Oh, I was gonna say we were gonna do a galaxy first, but I think I wanna. No. I can't see the whole double cluster. I can only see one. Okay, I'll later in the season we'll be able to see that. Right now, I want to do this other object that we've talked about. Okay. Over here is the Triangulum Galaxy. And it's at 46 degrees in altitude. And let's see if we can go there. And sure we can. Yeah. Is it that right there? Can't tell. It's not. Or is it that right there? Either way, it's close. No, let me try something. Let's let it stabilize here for a minute. I'll actually try this anyway, just to see if it knows where we are. Okay. Ah, just out of view. Okay. So it is just out of view. So let's do this. Because we're looking for it, I'm going to solve for it and put it right dead center in the view. So here we go. Okay. Let's do a quick shot. 10 seconds. I think this is it here. Right there. Yeah, okay. So what we'll do is we're going to move this in. Well, first of all, do this. Oops. Other left. Here it comes. This is going to be a kind of a showpiece. This is a really beautiful location. All right, there's one more jog. All right. Okay. All right, and now let's go out and see if we can grab ourselves a guide star. And we may not have one that's very bright, but we're going to find out. Oh, yeah, we do. Very good. Okay. Excellent. Okay, so now we're going to come back here, and now we're going to do a 30-second photo of this galaxy. And you're going to see some immediate beautiful structures in this galaxy, which is almost 3 million light years away, 2.8 million light years away. Okay. Exciting. All right, let's see our first one. Oh yeah, look at that. Yeah. Now, I think yeah, I have let me do this. Just a second. Okay. I'm trying to figure out the orientation I have to do here. Okay, just a sec. We don't have clouds, do we? That'd be pretty weird if we did. Let me go look. I gotta refresh. No, we don't. All right. Okay. I'm gonna clear that because I don't like that. That wasn't right. Yeah. That's better. Excuse me. Okay. I just have to do one thing. I've got to move us over a little bit, which I'm going to do. Astronomy sometimes takes time to get things right. Okay, so that's the 30 seconds. I'm going to move this here and down a little bit. Center this up, in other words. Okay. So, I'm going to move it down a little bit. Yeah, I know. All right. All right, I think that's good. All right, and now our guiding is commencing again. All right, guys, well, here we go. Hey, Isabella. This is nice to see you, Isabella. This is Measure 33. So we're doing a 35-second shot. I didn't see you come in, Isabella. So nice to see you. Okay. So we're gonna go low light now, and this guiding here, I believe, is going well. Yep. Look at that. That's nice, reasonable. And you'll see Measure 33 filling this frame. It's gonna be too big, but the center should be right about here. Okay. And I wanted to catch this guy, but I couldn't, but it's all right. Oh, look at that. Now, there's a few things we got to do. We're going to do this. That's going to be too bright. Actually, let me get rid of this right here. All right, and now this goes here. And one thing that is interesting, which is really cool, I should have brought it over a little more. You could see details in like this right here, this ionized region. You can see details in this. Okay. And I just don't have it right. I gotta get it. I'll leave it like this for tonight, but it's really not the best framing. Okay, let me come look here. Let's come over here. Pull in here. Oh, we're upside down. Duh. Yeah. All right. Okay. Alrighty. Well, for the first time, we can actually see detail in nebula's galaxy's nebula that's literally 2.8 million light years away. We haven't been able to do that before until we had this telescope. This is perfect. See the blue spiral arms? Really nice. Darn it, I really want this thing in here. I need that in here. I think That's making me crazy. Sorry. I gotta start again. I have to start again. It's making me crazy. Making me crazy. I have to do it. I'm sorry. Yep. Making me crazy. That's better. There it is. Okay. All right, that's better. That's what I wanted. Okay. Sorry, guys. Now I'll do it one more time. All right. Okay, and off we go. Okay. Pretend we didn't see all that. And now we're going to do this one more time. Okay. We'll just do 30 seconds. We're not going to do 35. It's the last object, so I'm trying to get it right. Ronald says, I'm glad you picked this scope and size. Yeah, this is a good size, Ronald. If we were to get a good grant, I'd get upwards of a 17-inch scope. So we can actually do some really cool stuff. Okay, here comes our first image of Measure 33. We'll see this guy. There we go. Okay, that's better. Let's see. What? Yeah, 604. That's NGC 604 over there. So I may have this. Probably needs to be this way. Okay. Just listen to the pretty music as we get some images. Yeah, no, what I did was I swapped its image size. That's okay. Let's cut this. Interesting how it does that. I don't understand. Okay, probably because I have to do this one more time. Okay. That's more like it. Alright, that's what I wanted. Okay, NGC 604 is right here. And this is another one here. This is another stellar nursery star forming region here. And the spiral arms will show up as blue here shortly. Okay. And we're doing it at 200 sensitivity. Again, we're only seeing part of the galaxy, but I want to show you this guy and this guy in the same view. And there's a little more down here, but we can't see the rest of the galaxy, which is over here. But that's really nice. Alright, let's see where it wants to be. It's going to make it pretty bright. Let's turn off the unsharp mask for now. Okay. And come back here and adjust our levels, because that's very important to do. Right up to the top of the curve, get it as dark as possible, and then pull this mid-level one down to get rid of some of the noise until it can support. It's interesting to think about this, but we're seeing this happen live. This is happening now. It's a live event. The light you're seeing hitting your eyes right now from this object left 2.8 million years ago from the galaxy. And the speed of light is the fastest speed in the universe. And it took 2.8 million years to get here. It's by far not the farthest galaxy. There's galaxies billions of light years away. Billions. So the universe is massive. Yeah. I'm studying the quality here, seeing if I like it. So far, I'm not sure I like the quality. We might have... Yeah, there might be some turbulent air now. Earlier, it was beautiful. Okay. Okay, so here's the annotation, so you can see the center of the galaxy is here. This is NGC 595. This is NGC 604. Again, H2 or ionized hydrogen region, star forming region, very furiously star forming here. Not as furious, but still active, very much so here. You also see all these others that are marked here. That's not all, because there's one here that's not marked. There's some here that aren't marked. There's subtle one right here that's not marked. So, you know, we actually see a lot of these objects in here. And so, clearly, here's like an association. This area here and this area here, just like in the Andromeda Galaxy, is an area of hot O and B type stars. O's are very hot and blue. B's are hot and blue as well, but not as hot as O's. And when they form together, they form associations, or form clusters, so to speak, of those types of stars. And so these are called OB associations. Then up here, in NGC 595, within this galaxy, we actually see this ionized hydrogen gas in here. So we have beautiful red nebulae. If we're in this galaxy, you could see that. It'd be a stunning. This might be look like the Orion area to us. Yeah, let me bring that back up. Where'd it go? Oh, duh, it's here. Alright, so we'll restore that. Okay, we'll save the image with annotations to M33. Very good. And come out of there. Yeah. That's better colors. That's really pretty. You can see the details in the galaxy right here. That's something. Look at that. That's really nice. Let's zoom in on that. Again, you can see all the nebulae in here that are all the nebulae that we know is in Mesher 33, but you can see all this dark nebula in here too, this dark dust. Then we have this guy, which is just really detailed, and this guy, which is really detailed. Unbelievable. Really pretty. Make this get a little bit lighter. Oh, yes. Look at that. So, was this worth being the last object, guys? Ronald asks, in comparison to the Milky Way, how old is it? I'd have to look and see how old the Triangulum Galaxy is. Because ours has been here for billions of years, so I assume this one has 2. We're all kind of in the same condition. Yeah. Okay, I'm going to just save 17 here. Actually, I'll save it when it gets to 18. We haven't lost a single one yet. Alright, save. Save exactly as seen. I'll try working on that one. There needs to be a little bit more to get this scope looking good. In other words, to get this image, looking good. We'll get to 20 and then we'll call it. Jessica, where is that treasure called Beyond the Map's Edge? She may not want to tell you now, Ron. Okay, 20th image coming up. There we are. So, Sally Forth, that's a nice thing to say. A nice, beautiful ending to the night, to my night, she says. Excellent, thank you. And we're gonna save this here, and it's almost the whole galaxy. Okay, but we're missing a few bits and pieces over on the right. Okay. All right, guys. Well, you've done it again. You've blown another couple of hours with Skytour live stream. I hope it was worth it. It was worth it to me. hopefully it was worth it to you. If you guys want to visit our store, that'd be great. At on Etsy called Sky Tour Shop. You could also consider donating, supporting our Patreon, if you will. Join us. Also, skytourlive.org. There's a donate now button if you want to help us out. That's fantastic. I don't get any money for this myself. This is all going to furthering what we can do to get astronomy out there. I've actually, I'm trying to work with Harvard University now in teaching some astronomy, and that so far looks promising. I'll be talking to them about that. I won't be going there. I'll be doing it with these observatories. And it wouldn't ruin SkyTour Livestream. It'll enhance it because we'll be doing SkyTour Livestream together with a class, and you can still all come in. It's not a problem. Hopefully that'll work. Anyway, thank you for all your support. We still need you, and I hope you guys have a good night. And I'm gonna go to bed now because I'm kind of tired. You know, I got up early. You know, I had to go to a birthday party yesterday. It was really far away. And I finally came back, so it's nice. All right, guys, have a good night. And if I don't see you before I go to Nova Scotia on Thursday morning, you have a good rest of your week. I won't be able to stream in Nova Scotia, but I will be back I'm leaving Thursday. I will be back Monday. So we'll see you guys. Have a good evening, and sayonara. Good night.
Stars so bright in the sky, on Arizona nights they fly. Nebulae in colors rare, galaxies beyond compare. Sky tour in the night so clear, brings the universe near. Real-time wonders to see, streaming light for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds, stories of the cosmos told. Through the lens, a distant dream, living real like a gleam. Far away, up so high, across the stars beyond the skull. Through the lens, a distant dream, living real like a gleam. Lift your eye up so high, across the stars beyond the sky. Sky tour shows us the way, every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light.